All right, we should be good. Folks can hear me down the back? Yes, good, cool. All right, so I'm here to talk about some stuff we've been thinking about for the future of entity framework. So in my last session, we kind of talked about what's going to be there in RC1. This is more forwards looking. So I'm just going to run through, I have 5 different kind of scenarios or features or things we're looking at adding. So I'm just going to kind of run you through. This is all brainstorming at the moment, so we don't really have code to demo for any of them. So I'll be mostly in slides. I do have one that I can demo for you. I'm also up here as a PM sharing stuff that we've been working on, but I want to make sure I don't take credit for all these ideas. So I'm going to tell you whose idea they are and who did all the work when we actually get to them. So this first one I'm going to talk to you about, which is called read-ahead query materialization, was an idea of Andrew on our team, and he's been prototyping it. So if we look at the query pipeline in EF at the moment, this is kind of what it looks like. You don't have to understand all of this, but effectively this is what happens when you run a link query. And there's really 2 parts to this. There's the part where we interact with the database over here on the left. And then on the right-hand side, we have all the stuff that happens in memory to create instances of your entities and to stick all of those in the change tracker and do identity resolution based on primary key values and all those things. And so effectively what happens is we run the query on the database, we get the reader back, we take the top row from the reader, and we run it through the materialization pipeline. And then if there's more stuff left in the reader, we get the next row and do that again. So one of the things that we've been prototyping is to introduce a second thread so that we use 2 threads to materialize queries. Now, I just want to clarify, this isn't something you would do all the time. This is something you would be able to opt into if it made sense. And so when we do that, we use one thread to effectively retrieve all of the data from the database and keep dumping that into a result buffer. And so you see here, we basically just keep fetching rows from the reader and bringing them into memory and then leaving them in a buffer. And then in the second thread, we basically loop through all the data coming into the result buffer and run it through the materialization pipeline. So we basically have 2 threads going in tandem, one reading data from the database into memory and the other taking that in-memory data and materializing it into objects. And to give you some idea of the gain you can get from this. Obviously, if you are working with small sets of data, there's little gain in this. But when we start talking about big sets of data, like the end of this line here is 100,000 entities, then you start to see some pretty significant performance improvements in terms of time elapsed that it takes to materialize all the data. So just to set some parameters around this, obviously not something you'd want to use all the time. It's good for larger result sets. In the prototype we did, around about 100 entities in the result set is about when you start to see better performance out of this. If you go much below that, the cost of spinning up threads and sharing data and stuff outweighs any benefit you'd get. The other thing, obviously, you would only use something like this when threads are not in short supply. So if you have an underutilized app server or you have a client application where there's not a whole bunch of things competing for resources. Any questions or comments on this little idea? Nope. All right, I'll keep going. So while we're on the topic of perf, I just wanted to share a little bit of stuff about some benchmarks we're getting with EF7. So the folks that have been doing the work here would be Andrew and Arthur from our team. So Damien talked a lot about benchmarks, and they obviously don't represent the kind of performance you would get in a real-world application, but they are useful because they let us kind of know how we compare. So at the moment in EF7, the biggest thing we're doing with benchmarks is drilling down into small scenarios in the stack and then looking at how those compare, particularly to EF6, because we want to be faster than EF6. We have our own benchmarks, but there's also some external benchmarks that people set up. So these are some results we had yesterday from some query improvements that Andrew's been working on. So this, Franz Baumer, has some data access benchmarks he's used. Historically, EF6 has not done very well on these. But some results we got yesterday. These, obviously I'll just caveat these. These were run on our local machine with a put together prototype and stuff. So this isn't the performance you would probably get from what's coming out in RC1 or anything. This is stuff we're working on for post RC1. But you can see here, EF6 used to be the second to last on this list, and now we're actually ranking 3rd with EF7. Interestingly, on this one, we're actually faster than Dapper for this particular query, which is pretty cool. And then, obviously, different scenarios work better with different stacks, and so we're not faster than Dapper in this other one down here too. But Just wanted to share that to show that we are really making some progress in EF7 in terms of performance. Then I also mentioned we have our own benchmarks as well that we use internally. So they are part of our GitHub project. At the moment, while our code base is churning, they're actually in our main repo, just in our tests directory. In the future, they'll actually move out into a separate repository once we stop breaking all the APIs all the time, which will be soon. I'm going to share just a subset of results here. I want to be clear, I am picking some good results. We have some results that aren't so good at the moment, so I am cherry picking a bit here, but this is a set of micro benchmarks we run for initialization. So interestingly, like looking at create and disposing unused context. So if you have an MVC application where your controller takes a context into its constructor, but it never does anything with it, then you're creating a context, but you're not using it, and obviously you're still incurring the overhead of that. And so we've made some significant improvements in the time taken for that. You can see, like, for the first time it's created, there's a 73% reduction, and for every subsequent time, we're about 65% faster. And then we're also looking at if I create an instance of a context and then run a query, or I create an instance of a context and then run something through the save changes pipeline, we're also seeing significant improvements in those too. And then, of course, you're probably looking at the top one saying, why is building the AdventureWorks model 10% slower on EF7? We actually have a change being worked on at the moment. It'll probably go in this week that'll bring that back into the green for EF7. Any questions on perf, comments, anything? Yeah, down the back. The question was, do we measure memory usage? So we do measure some memory usage, which is to, over the duration of the test, to make sure that we aren't leaving a whole bunch of memory allocated that we shouldn't be. So we look at the start of the test to the end of the test, how much did the memory usage change, the currently allocated memory. Those numbers are pretty much across the board green on EF7 as well. The one that we're still working out how to best measure is to work out our peak working set for the duration of the test that we care about. The thing we're finding difficult is the test runs, has a whole bunch of infrastructures. We're really trying to narrow in on a particular part of the test. And so it's difficult to get peak working set for that particular test. I think memory usage is going to be easier when we look at profiling like a real application that's running with a huge number of incoming requests and look at the peak working set while that thing's actually running. Yeah, another question.
For that cold one instance, if you have an MVC action that's taking in an EFP context, is cold like just when the app first starts? Or is cold every request?
So the question is, what does cold mean? Cold is first start. So the first time in, depending on how you're doing caching, but really the first time in an app domain is what we're talking about. We do, if you follow our patterns where you just write your model creation stuff in on-model creating and you register your context in the service provider using our pattern for that, then it'll be once per app domain.
After that, everything should be like the warm.
Yeah, you'll get the warm figures after that. Obviously, so for example, in multi-tenant scenarios, you'll take care of model caching yourself because you'll have different models for each tenant that you're connecting to. And so you would pay effectively the cold start cost every time you build that model in a different way, but then you would reuse that for subsequent context to the same tenant. So you'd pay cold once per tenant and then warm from then after. Cool. Anything else? All right, so one of the things we talked about with EF7 when we first started looking at what we're going to do was the ability to connect to non-relational data stores. So I wanted to quickly take a look at a couple of those. Two that we prototyped were Redis and Azure Table Storage. So we're going to take a quick look at those. I wasn't able to get our Redis prototype up and running again at the moment, so I'm just going to kind of talk through what we think that would look like. So the work I'm talking about here was done by Andrew and Lawrence on our team. So I wanted to quickly set an expectation of exactly what we're talking about when we talk about a Redis provider for EF7. What we're talking about is I have a context, I have some entities, and I want to stick those in a cache and be able to access them. What I'm specifically ruling out for that is we're not talking about having data in Redis in any given format and being able to map that to an EF context. The other thing I want to point out too is that we're not intending to abstract away what type of data store you're connecting to. So if you have an existing model that's hooked up to SQL Server, we're not trying to make it so you can flip one line of code and automatically have all that mapped to a Redis cache or to Azure Table Storage or anything like that, because there are nuances about how data stores work and everything, and anytime you try to do that, it works great for some 101 samples and it breaks down. But on the flip side of that, you can do that. If you're willing to you'll have to write a bit of extra code to say, when I'm connecting to SQL Server, this is how my entities map to the database. When I'm connecting to Redis, this is how you shred and unshred my entities from the cache. And so you could retrieve data from a SQL Server database and then store that in a Redis cache using EF and using the same domain classes if you wanted to. So I'm going to give one example of how we can shred. Obviously, there's a huge number of different ways you could shred an object graph and store it in Redis. This is one idea that we used in a prototype, but it's certainly not the only way to do it. So given the code that I've got here, which is a very simple context, which has a user class with a username as the primary key, and you can see here I would use some kind of extension method in onConfiguring to say I want to connect to Redis, giving some kind of connection information. Then we would, basically Redis being a key value store, we would store a whole bunch of different values in there. So the first one we would do is we'd have a value, which is a set type, which stores all of the known primary keys. So if we want to get a list of all of the keys that exist for this given entity type, we would pull the value out of this key, and it would be probably an ordered set with all of the different primary keys in it. And then we'd have other key value pairs, which would use the hash value type to basically store the properties and their values shredded into a value. And so given the key index, we could work out that there's a user called Roe Miller, and we could go and then look up the appropriate value and then use the hash from that value to materialize it back into the entity type. So that's kind of what we're thinking along the terms of Redis. Any feedback, comments, questions about what we're talking about here? No. I guess the key takeaway from this, like I said, we're not talking about just I have some arbitrary data that I have cached and I want to be able to read it. We're talking about EF having probably more than one, but some very opinionated patterns around how it would actually be able to shred that data. So think of it more as I have an EF model set up and I want to put it in a cache, as opposed to I have some data in a cache that I want to be able to read into EF. All right, so the other provider we looked at, which we actually did ship a very early prototype of, is Azure Table Storage. So I'm actually going to show a very quick demo of this. Folks may have seen this before. I think I actually showed this briefly in one session last year, perhaps. So we're just going to run through what an EF model would look like hooked up to ATS. So I have a POCO object here. It looks the same as everything else I would use. This is recording entries with key cards going through doors in buildings. So we're going to record the door that it went through, the time that the card was swiped, and then we're also going to record the card number that was swiped and whether the request to access the door was granted or denied. Now what's interesting with Azure Table Storage is that I don't just have a primary key, I have a two-part primary key. I have a partition key and a row key. And so when I talk about not trying to abstract away the data store, when I hook to Azure Table Storage, I need to go through the entities in my model and tell it what the partition and row key are. And so here we can see Azure Table Storage. We're saying the partition key is the door and the row key is the time code. And then in onConfiguring, I'm basically reading a connection string from my config file and then using an extension method that's available because I have the ATS provider installed. And then same as I would for every other type of data store, I have a DB set exposing the types in my model. And then I've written some code here to use the context, so I create an instance of it. I call this same high-level method on EF to say make sure the data store is all set up, ready to save my data. I create some instances of my card entries and I go and put them in the DB sets. And I call save changes to flush all that out to the data store. And then later on I create a new instance of my context. I use a link query to get all the data back from the store. And then I just loop through and write it out to the console. So I just go and run this. So we see a bunch of data coming back. And just so that you believe me that it's actually talking to ATS, I have Storage Explorer here. And when I refresh, you should see some extra data pop up from that request we just ran. Yeah, so we're seeing data going in and out of ATS. So a couple of things to point out. Well, actually, first I should say the table storage provider was prototyped by Nate on our team. So with these providers we're doing, we're not trying to replace a native SDK. So obviously for Redis and for Azure Table Storage, There are perfectly good .NET SDKs you can use today. Where we see the EF one providing value is when I'm already using EF and I know how it works and I use those patterns in my application and I want to use EF. So I just wanted to point out we're not trying to tell people not to use the native SDKs. I already mentioned that it's not intended to abstract away the type of data source. So we saw that when I connect to ATS, I have to tell it row and partition keys. And then the other thing we need to be careful of, obviously with link queries, you can write some stuff that's going to be really gnarly when it runs against ATS. If you do a filter on something that's not the row or partition key, you're going to get terrible performance on that. And so I actually showed in my session on Monday that we have a kind of setting for dealing with client evaluations. So when you're running against SQL Server, at the moment, our default is we write out a warning to the log if we do client eval in a link query. But obviously, running against ATS, we probably want to actually throw an exception. If we detect a query that's going to do like a full table scan, we probably want to throw and say, look, change this flag if you really want to do it. But for the most part, this is probably not what you want to do. Any questions on ATS? Yeah, question.
Yeah, the problem that I see there is with the storages that will happen in the future that doesn't support any type of query.
Yeah, so the question is, what about storage that doesn't support query? So obviously, we expose link. Not everything is going to work for every data store. Obviously, we try and encourage providers to do the best thing they can in the data store and then do in-memory evaluation if they can't. But of course, like I said, in some cases, there's going to be things where you throw. Yep. So with
go to the storage, get all the data back, and then do that in memory.
Yep. So we certainly don't, I should say, out of the box, if you just map it clean to the store, you're certainly not going to be able to do things with link that you couldn't do with the native SDK to query and have them be suddenly performant. Okay, you're going to, basically, link is just an abstraction over what we're doing. So same with SQL Server. If you write a horrible query in link, it's going to be horrible in SQL. That said, we have some ideas with Redis where you can say, look, I'm interested in filtering on this property, and so we'll actually build some kind of index for you in Redis to keep a track of values for those entities. So we have some ideas, but I think also with link, we don't want to have every query like just automatically work out of the box. Now with our relational providers, for the most part, relational providers have really good query semantics, and so we can have almost every link operation work out of the box. That's not going to be the case with other data stores. There'll be cases where we have to throw and say, you can really do that if you want to. Like if you know you've only stored 100 customers in your ATS store, then go for it, run this query. But if you've got 1 million rows in there, then you should not do this. It's going to perform horribly. So, yeah. Other questions? Comments, ideas? Look like a stupid idea? People think this would actually be useful?
Actually, I think that is very useful.
Yeah. So useful, but we just need to make sure we make it so you don't get terrible performance without knowing it. Is that fair? Yeah. Yeah, question here.
Now you have DocumentDB as well.
Mm-hmm.
Why did you choose table storage, not DocumentDB itself?
So the question was, why did we choose ATS instead of DocDB? Probably just timing on it. We started prototyping the ATS provider quite a while ago. I actually hacked together a very dirty prototype of it to start with, and then Nate came and joined us as an intern and picked that up and turned it into a real provider. So it was more just about timing. We are talking with the DocDB team. We think it would be a great thing to write a provider for. It may be our team that does it. It may be their team that does it. We're not sure yet. But yeah, we think a DocumentDB provider makes a lot of sense. So, yeah. The other thing I should point out here, obviously, when we talk about mapping to these other types of data stores, they don't support foreign key relationships in the database. So in the core of EF7, we actually decided to keep the concept of a foreign key around, because having a value that's used to look up the primary key of an object in a different place in the data store actually makes a lot of sense. So we still support the foreign key pattern in these cases, but instead of doing joins in the database, we would individually go and select the appropriate data sets from the store, and then our state manager will just wire up the relationships for you in memory. Now, obviously, that means if you're doing filtering over foreign keys, we possibly need to do our own indexing over those things in the data store to make that performant. But we think, or what we've seen so far, is that the idea of relationships based on a foreign key, although they're not natively supported by the databases, they do work in most databases. So, cool. Anything else? Questions? Yeah.
What about transactions? People
Yep, so in terms of transactions, we originally made transactions just a relational concept in EF, obviously realizing that other data stores would have transactions to some extent as well. We just promoted that to a core concept in EF7, so that's not in RC1, but after RC1 there's the central idea of a transaction in EF7. It's going to depend on the store. So obviously on some data stores, save changes is not going to be transactional because that's just not possible with the data store. Obviously, if you're explicitly calling transaction APIs, then that's easy, we can throw. And so for example, with our in-memory provider, which is intended for testing purposes, if you try to start a transaction on in-memory, then we'll actually throw and tell you can't do that. But specifically for in-memory, we have the option to say just no op when I try to start a transaction so that I can use my same code against my real database when I'm running the application and against the in-memory database when I'm testing. But I think that's going to be true for all of the non-relational providers. It's going to be up to the store to work out what makes sense to do for this particular store. Yeah. Any other questions or comments? All right, so another thing I wanted to talk about was just the ability to do more flexible mapping to CLR types. So if you look at an entity that's used with EF these days, they typically look like this. They have just a property, they have a whole bunch of properties with getters and setters, and you can't really put a whole bunch of logic or methods into them. And a very common piece of feedback we get is that EF should allow more flexibility in what it can map to. So one of the things we've started looking at is mapping to fields. So you can see in this example, I don't really want a get and set on my blog ID. Instead, I've moved it so I have a private field, which is called _blog ID, and then I have a property with a getter on it, but no setter, which exposes the blog ID. This actually partially works in EF7. Our query pipeline, if there is a private backing field, our query pipeline will go and map to that field. Obviously, it has to match some conventions, but for most cases, we'll find the backing field and we'll start actually pumping the data straight into the backing field rather than calling your property setter. But there are still places in our stack, like our change tracker and things like that, where we actually do still want to interact with the setter on the property. This is something we are looking at enabling in the future, but it's not quite there in EF7. Yeah, question?
Was this enabling IEnumerable support?
IEnumerable for a collection navigation?
Yep.
Not yet, but I will talk about that in a little bit. Actually, is Arthur in the room? He may be able to correct me on this. Do we just try and call and add if the return type is a list? Okay, so if your return type on your property is an IEnumerable, but the actual type that you return happens to be an iCollection, then we will call add on it. So we'll basically try and cast, and if we can actually add into what you return, then we will do that. That's obviously not really honoring the contract of your entity because we're trying to cast your IEnumerable to an iCollection, but it will actually work from public surface point of view. So, yeah. I'm going to get to some more patterns around collection navigation properties in a second. Now, another alternative to having EF map directly to the private field and kind of push into the private implementation of your entity, another one we want to support is constructor parameters. So in my case, I've put a constructor parameter for all my properties, but I may just want to put a constructor parameter for the properties that don't have a setter. So I could also do this with having just blog ID there, and then have EF interact with the actual URL property get and set here. And then pushing this on just a little bit further, we could have, instead of having setters for any of our properties, maybe we want to put some logic in the setter, which we're not really supposed to do in properties, so maybe we want to have set methods for our properties. And so obviously here, I'm really just writing to a private field, but I could do some validation on the value being set. I could do some other changes related. So there's another pattern, and then we'll just keep pushing a little bit further. And we could do away with the property altogether, and we could have get and set methods for interacting with our properties. And then one other pattern I just wanted to talk about as well is the idea of a property bag, where I have properties or fields or get and set methods for some of the properties on my object, but then I have some extra stuff. Perhaps I'm in a CRM where customers can dynamically add properties to the entities. And so I want to have some kind of property bag, in this case a dictionary of string to object, where I can just stuff all of the extra stuff that's not actually reflected with a property. And then pushing on just to one more example, which is kind of what you're asking about a minute ago with collection navigation properties. At the moment, you have to expose an iCollection navigation, or like we said, you can expose an IEnumerable, but the return type from that needs to be an iCollection so that we can add into it. I will say the set method, the setter here on the property is actually optional. If you don't expose a setter, but you make sure the collection is always initialized, then EF will still work with that. But one pattern that people would rather do is expose an IEnumerable and then have add and remove methods so that you can write logic and validation and all those things that go along with adding and removing from that collection. These are kind of the patterns our team has been thinking about, but I wanted to open it up to see if folks have other patterns that they use in their domain model that we haven't covered with the examples here. No, this is the totality of code that people write? Yeah.
Collections of values.
Oh, collections of values, that's a good one. So I think that actually goes beyond what we're talking about here. So here we're talking about having a property of type int and just different ways to get and set the value of it. But yeah, being able to have a property which is a list of integers or an array of strings or something like that, that actually falls into another feature we've been talking about, which is type conversions. So if I have a property of any given type, maybe I have a XML property or I have a spatial property, and I want to be able to say, this is how you serialize and deserialize that to the database without EF having to go and add lines of code. Because in EF6, for every type we supported, we had to add lines of code to say how to serialize and deserialize that from the object. In EF7, this isn't supported yet, but we have architected things in a way that will allow arbitrary type mapping in the future. And so, yeah, we'll be able to say, you know, you fetched it from the database and it's a string data, but you want to put it into a spatial data type or, you know, a URI data type in your object. And the same thing would be true from collections. We'd probably want to have, you know, a list of int here, but we serialize it into a comma-separated string or some other data type in the database as well. Yep. Yeah, down the back.
For the example here, what type does IEnumerable post have to be? Does it still have to be an iCollection, or can it be like a read-only collection or something that they can't cast?
Yeah, we would honor the contract in this case. So we would, the way our stack works at the moment, we only try to cast it to iCollection when we actually need to add something to it. So if we never need to add, depending on what you write, so if you're just querying, then EF can create the collection and set it. I guess that probably wouldn't work actually, but we only cast it when we actually need to add things into it. And so the same would be true here. We would never need to add because we have a method to add and remove. And so we would never attempt to cast it. So yes, it could actually be something that is just IEnumerable and not iCollection in this case. Yeah. Which is obviously what you'd want because you don't want people casting to iCollection. That's the point. Yeah.
But you're also saying in that case, it sounds like the EF would call my add post method.
Yeah, EF would actually go through these methods if you told it to. Yeah.
I would like the EF to be able to populate this thing, but not call that because add post should only be called when like the user is actually adding a new post, not just EF just got this thing out of the database and pulled it.
Yeah, absolutely. So in that case, we're talking about I want EF to be able to kind of create this thing behind the scenes for me. I don't want EF calling add post and remove post and things. So in that case, that probably lends itself better to private field mapping. So you have a private field that is an iCollection, and then maybe you cast that to a read-only list or something when you return it from your IEnumerable property. And so, yeah, that would be covered by private field mapping. Yep. Go on. Other questions or feedback? Yeah. Getter-only autoprops. Yes, so if we go back an example, I was using C#6 syntax, but if we go back to this one here, blog ID becomes a getter-only property here, and we're mapping to a private field in the background. I'm using, this is like a C#6 syntax to say there's a getter on this property that returns this, but this would be the same as writing a get accessor with just some data in it or some code in it to return the field. So yeah, that would work. In that case, you could either go through a method when we support that, or you could just map directly to the private field and have EF do it that way. I should point out we do actually support private setters both in EF6 and EF7. So if you don't want the setter to be exposed to the application code, but EF can kind of duck under the covers and use a private setter if it needs to. Yeah.
What about in the case where there was, like, using the URL property as an example of where it was literally just the get, and then the compiler was
So if we go, where did I have that? Oh, that was when I had the method, right? Oh, I guess kind of here. Yeah, if we can find a backing field, we will use it. So it's actually an interesting change in EF7. In EF6, we would only map fields that had a getter and, properties that had a getter and a setter. In EF7, we map all properties. And you can, of course, say ignore this property if you don't want it in there. But by default, if you have a property, we will map it and we'll try and find, if it doesn't have a setter, we'll try and find a private field to map to.
The private field in that case would have the goofy compiler name like
Yeah.
underscore.
So we detect the compiler name, and then I think, Diego, do we also detect underscore lowercase property name? We do. So we also detect this example here, obviously, where I'm using the property name, lowercase start with an underscore in it. We'll also detect that by convention as well. And there's no first-class API for it, but you can actually kind of duck under the covers and put an annotation on the metadata to say use this private backing field if you have a different convention as well. Yep. Yeah, you could use a constructor. At the moment, constructors are not supported in EF7, so yeah. To be clear, apart from the first slide I showed and the simple navigation property one, this is all future thinking stuff. It's not stuff that works now. And it's unlikely that any of this would be implemented by RTM of EF7. This is all post-RTM stuff. All right, any other questions? All right, so we've got about 10 minutes left, but you guys have another session over lunch, so we got through it pretty quick. So I'm going to let you guys go out and have a bit of a break and stuff, and then I think we have another session starting in here at 12:30 over lunch. So thank you very much.